Hello everyone, welcome to my YouTube channel. This is AstroDude slash Mitch. Today I thought we were going to do a video for someone who asked me if he could do from A to Z in Pixinsight all the works from part 1 to part 12 in one fell swoop. So Guillaume forwarded me some information on his data set, which was M31. It's 10 frames for the sake of the teaching or this training session for Pixinsight, going from calibration all the way down to a finished product. So there's 10 times 30-second frames. He shot at ISO 3200 on his Canon EOS Rebel T6 using a 70 millimeter f6.3. So we're going to go through all this through Pixinsight. From blink to sub and the whole rest of the way in one fell swoop. The whole video, hopefully it won't be 2-3 hours. I can hopefully try to do it in 45 minutes. The point is that he wanted to see one video complete without having to look at all 12 videos, which makes sense. I haven't done that yet, so let's do it. And it's a DSLR information. It's M31. And at the end, if I have enough time, we're going to talk about the do's and don'ts of astro imaging. We're going to talk about the ISO and the gain, how unity gain affects the ADU and high ISO and low ISOs on DSLRs. We're also going to talk about exposures. Should it be 30 seconds times 1,000, or should it be 3 minutes or 5 minutes or 300 seconds times 36? Things like that. And then at the end, we'll also cover the advantages of f4 over f10, the wise do's and don'ts of long focal lengths and short focal length for good imaging. Okay, let's get started. So, of course, everyone knows that to start, you have to go to the blink process and enter your light frames. And so here we are. He sent the frames as M31 for Mitch. So they're all CR2s from his T6. No, just a Rebel T6, Canon. I believe it's 18 megapixel. So we're going to let Pixinsight load that. A few seconds. On the longer on these longer processes, I'll just pause the otherwise it's always way too long. Okay, so the purpose of the blink, we're just going to look through his files, Guillaume, and see if he has any jets or planes or anything cutting across here, maybe clouds cut across. So I'm going through all 10 frames, and they all look really, really good. So that's good. Also, we're going to crop a section of it, like right about here. We're going to click on Preview, zoom out a little bit, and do the same thing, nice and quick. Now, either the guiding here was strange, or he's got excellent dithering, and I mean heavy, heavy dithering. This frame is all over the place, so very, very good. All right, so whoops, we're good here. We're good there. All the frames are okay, so we can continue on to selecting the best frame, which he has already done. But let's see what the subframe selector says. Clear the last entry, enter all of his light frames from M31, and hit measure. Again, I'm going to control pause. So we're done. I have a correction to make. According to Pixinsight, actually, let's look at the console. I can't look at the console while this is open. But according to Pixinsight, it reported f6.4 and 300 millimeter, not 70, is what I got from the EXIF of another program, which said 70 millimeter. So it really looks like 300 millimeter f6.4. Let's keep going. And of course that's saved. File, save, minimize. Let's up on the target and down on the plot. All right. So remember, all the way along, I've been teaching you to try to find the best full width half maximum. That's one way. There are hundreds of ways to do it. Well, not hundreds, but at least 3. And lately, I've been learning perhaps to start depending a bit more on signal to noise ratio. But for today, we're going to look at the lowest full width half maximum. Obviously, he ran it because it's already been referenced at 2.016, and that's his tightest stars on his lens, and his bigness 2.9. And at 300 millimeter, you expect one 199 to 3, which is very good at 2.5 and up. If we just quickly go over to SNR for a minute and do the same here, signal to noise ratio, and look at the, which is right here, 097 and 1.1, his reference frame falls about in the middle. So the highest signal to noise ratio, or we should say, yeah, it should be the highest signal, would be right here at 1.1. I'm going to read up more on this. Do you want a high signal to noise ratio, or do you want, do you want a low number, or do we want a high number? I'll have to look into that. But for now, we already find that the proper frame, the best frame would be at the moment right now, at the best focus, would be the one that he chose right here. So it's already referenced. I don't have to do it. I don't have to go into the software and name it because he already did. All right, dismiss. Dismiss. All right. Next step. Well, we need to load everything in to the batch preprocessing script. And once that's done, we'll have a frame to work with. So here's some things we have to keep in mind, at least for Guillaume, if this is directed towards him, but everybody can use this, is that it's a DSLR, it's color, it's RGGB, right here, VNG, and it has to be CF8, which is the color filter array, the Bayer matrix. So we want definitely to have that. The rest here, we don't have to touch anything. Defaults are fine. And integrating, because there'll be 10 frames, normally they want you to use percentile, but I always use sigma average. All right, let's go. Let's load his light frames. Here they are, all of them. Open. Go to his reference frame right here. Double click it. 1, 2, and it shows up right here under registration reference frame image. Now we have to output all these files, the final image, somewhere. So let's go back to C drive, temp, and there's Mitch, and we're going to make a new folder called calib, because we're going to calibrate all these files. Okay, so choose it. Okay, let's add the darks. Back up a directory, go to darks, add all darks. Same with the flats. Up, 2, and flats, and the noise you're hearing in the background is the lawnmower people who are cutting the grass. I apologize. Darks, flats, bias. Click on the bottom button here, bias, up, go to the bias files which he provided. They're all CR2s, all Canon. So there we go, 10 darks, 10 flats, 10 lights, with our reference image which is here, and this. Now, what have I taught you guys to do in for part 1 to part 12? You want to hit diagnostics, make sure that everything is fine. And here, according to the batch preprocessing script, it's completed, it's okay. In other words, everything matches. Bias, darks, flats, and lights are all okay in ISO and time. These are all 30-second exposures. So, okay, I'm going to hit run, and I'm going to pause because this may take 5 minutes. So let's just go run. Be right back. So that's done. So now we're just going to close the window, and yes, go directly to the folder which we created called calibration. And it created a whole bunch of calibrated lights, and it made some flats, and it made master flats, master darks, and master bias, and then it registered them all. See, C for calibrated, D for debayered, and then R for registered. What we want is the master folder with the master light. Here's the master bias, here's the master dark, and here's the master flat. You could keep those, I suppose, for later, but each session varies, so I wouldn't. The bias probably, maybe the flats, but never the darks. They have to be the same temperature, same night, same time. So let's look at the light binning, one by one, of the Canon DSLR T6. So here's what it rejected in the high. Not much. A few little hot and cold pixels. Hot pixels, dead pixels, cold pixels. So we're good. We're good there. And on the low, screw right in, zoom, 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 scroll, 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 nothing. But there's some dithering here, if that's what in fact he was doing. So that was taken out. So we don't need this frame. Say yes on that. And finally, the target. So there's always this screen transfer function up here, or some people like to use this guy. So suppose we can use this. Make sure you hit reset. Make sure this is linked and then just hit the nuclear button, and then M31 should show up. All right, so the whole image is blue. Why? Because his flats, whatever way he acquired them, whether it was daytime or using an LCD panel or an EL panel or whatever light source he used, this is where the blue came from. Sometimes when you debayer these and you have a light panel or use a sunlight for your flats, it ends up being dark green. Other times it ends up deep purple. I saw deep blue, bright yellow. I saw orange where you can't even see the galaxy. Now he did it in Deep Sky Stacker, and I don't know how it does its algorithms for flats, but this is what we got, and this is pretty good. So, all right, we can leave it at that for now. Let's just close the stream transfer function, and what we want to do now is I like to rotate this, go to geometry, and just flip it horizontal for now. Okay. And then I think it's 180 degrees. Just because M31 to me seems like there. That's what I'm accustomed to seeing. This has nothing to do with anything. I just wanted to put it in its just the way it's supposed to look when I usually see when I zoom into the dust lanes here. Usually I like to see that curve, those curves coming down here, and the little galaxy down here. So that's okay. So that's step one. At this point, because there was some pretty good dithering, I'm just looking at the top and I'm looking at the bottom, and yes, the pixels down here are offset, so let's crop. Let's do a crop. Ugh, what's going on here now? Dynamic background interface is already active in dynamic mode. Okay, that's very strange. Let's see what's going on here. Yep. It's almost like there's another window open somewhere. Of course, I don't see that doing that. Hold on a second. Undo. Let me see. Dynamic crop. Why is this not letting me crop? Oh, there's something else that's open. It may be this. I don't know. It's saying that some other dynamic background extraction. Yeah, but I just closed it. Okay, let me pause this and fix this. I've never seen this before, ever. Let me see if I can fix this and come back to you in a minute. I'll be right back. So the dynamic background extraction window was open here, and that was stopping me from using dynamic crop. For some reason, anything that's dynamic, a module, you can't use both at the same time. Now, notice these icons. I never had them looking like this. I opened those earlier because I was going to use them this way, but this might not have been the best idea, especially if they are dynamically used modules. And now I have to close. I had to close automatic background, dynamic background, and this dynamic crop. These three, they don't like living in the same window. I don't know why Pixinsight does that. Pixinsight does that. In any event, let's make a crop. All this crop is going to do, like, I don't want to remove his image because he's got lots of nice sky here, but this will speed things up overall when we're doing the rest of the work. So I'm just going to crop this so it's a bit smaller. Go back here. Now we're closer to the galaxy. Once again, I'm going to hit the reset. I'm going to bring it down a bit because there's been some pretty heavy dithering at the top. One more time. Perfect. Absolutely perfect. Look at that. Okay, so that takes care of the cropping. Double click the tab M31 underscore GP. It doesn't matter as long as you name it something. And what have I said 100 times? Save it right away, because if anything happens, you'll have to go back to your G bin or your light binning file, and you'll use that. You'll lose that. So I like to save it as I go along, to be safe, to be real safe. Of course, it's going to be an XISF, but it can be a FIT file if you want. Okay, step 2. Let's get to the crop. I don't think I'll crop this again. Step 2 is to remove this blue cast or green cast, and normally there's two things. It's either automatic background extraction, which we can try it right now, see how it does. Use correction subtraction, don't change anything, use everything to default, drag the triangle onto the image. And let's see if that blue goes away, because that's obviously not normal looking. Alright, let's move this back. Let's see what it took out. Stretch it. There's all your blue. Double stretch it. So that's what it removed out of the primary image back here. Let's have a look at the original now. This here, this one over top. Close this. And again, if you want, you can use your screen transfer function, which looks like I closed it. Or the icon up here. If I hover over top, it's STF. So let's open it up. Okay, so there it is. Very nice. All the background, all the blue in the background has now been gone. And now we have a pretty nice image with lots and lots of nebulosity. Keep in mind that this is excessively stretched. Here's the actual photo. You can see there's some stars and they're blue. And here is the screen transfer function. All right, let's keep going. Step 2. By the way, there are steps here. Beginner's grip on Pixinsight. So once we were calibrated, we went to step 1. We did a dynamic crop. We removed the edges of the stacked image, things that would cause Pixinsight to recalibrate, adjust the colors, make color changes. We don't want to incorporate the ragged edges. We want the image to be clean. So in this case, I just cropped it to make it a bit smaller. Now it's either a dynamic background extraction, which we just did and removed all the blue. In some cases, it's green cast, being a RGB chip from Canon. And neutralizing the background is going to be next, and then we're going to calibrate the color. So background neutralization. Let's find a spot in M31 on the background, way down, an open area, or at the top, right here. And let's use background neutralization and make a small window. So click here. Make a small preview. Try not to include any stars. It doesn't need a lot. Okay. Go to reference image, which is our preview. Select preview 1. Okay. And zoom out a little bit. Dump, dump, dump. And just drag and drop it. And you probably see barely any difference at all, but the background has been neutralized, or has been put back into the RGBs. Normalization has happened in the background to the proper color. Now, again, I close it. We won't need it. Now we need to calibrate the entire image. See how blue this is? Now, in the advanced mode, you can use photometric color calibration, but today I don't have enough information for that, so we're going to do it the standard, slower way. Two things. Some people do a second preview and they select the core of M31, which would be preview 2. So in color calibration, we're trying to make all the stars white and the galaxy its natural brownish bluish color. So reference frame for white, we're going to go to the core, which I just chose preview 2. In the background reference, it's our original background preview 1. Okay. Make sure structure detection is on, drag and drop. Let's see if it goes neutral or funky. Wow, that's excellent. The stars are pitch white. The galaxy's gone back to its natural color. Excellent color calibration did a very good job. We can close it. All right, so we can remove the little previews, remove all previews, delete all previews, and now we're back to the original galaxy. And do this. My computer's acting up today for some reason. Now, we are done with this, but I like to keep that copy. So I just put a 1 in front of here because it's the original blue one with the flats. I'll just save it. And then I'll just close it. And I'll bring this one up and I'll rename, double click on the tab here. And don't need to keep the GBE in there, but A for my first version, B will be for my second, and C for my third. You know, use whatever name convention you want, just to remember that that's where you're at this point. So okay, this is back where it is. Now we are in linear mode. In other words, everything across the board has not been stretched. This is how it came off the camera. without being any type of application, any type of stretching. This is stretched, and this is unstretched. So before we stretch this in real time, before we go nonlinear, we have to deal with the noise. And if you notice here, being that he shot at ISO 3200, then there's a bit of noise, more than we would like to. The next time Guillaume shoots, when I have a little talk with him, will be to bring the ISO back down to 800, have longer exposures, and we'll talk about that later. So, all right, for now, let's do whatever step 3 is. I mean, I know what the steps are. I'm just trying to go in logical order. Okay, so you know what I like to do also at this point? I'm going to extract the luminance channel by pushing right here. See this little button here? Extract luminance. Here it is. And we're going to stretch it so it should just be a black and white copy. And I'm going to double click that and just put luminance in front of it. Should be okay. Now, in order to deal with any type of noise reduction, because that's step 3 or 4, depending on how you count, we need to put a mask on. If you look at here, and look at here, and if we're going to do any type of denoising, we need to create a mask, and we did that by extracting luminance by that little button up here. And this is our luminance channel. See, and if we put them one on top of each other, they perfectly match. Okay. Now, let's take that mask and stretch it first. So unstretch. I know this is all weird, eh? Haven't done this in a long time. And all process, bring back the STF, screen transfer function. I have to stop closing that and leave it open. So this is linked. So I'm going to, and oh, please open up the histogram transformation because these two guys work together. So on the luminance, stretch it, grab the triangle, bring it and drop it on the bar down here. Then reset the luminance and drag the triangle onto it. Man, it took me a long time to learn that the first time. Even though I watched it 3 times, I would always get it wrong. Grab the tab, drag it onto the original image, and minimize. Do not close your mask. Do not close the frame. You need it open. You can reset this, and you can close that. Now, anything in red is protected. Everything in white reveals. So obviously we don't want to denoise the core. We want to denoise the background. So mask invert. Now the galaxy is protected and the other galaxy is protected, and some of the background is exposed, and we can deal with some of the noise there. Of course, you don't want to watch it red like this, so mask, don't show mask. Okay, we're back. Create a small preview to where you're going to be working for the noise. So I would choose between, the edge of the galaxy and the other one. So let's zoom in. There it is. All right. It's pretty good. Let's keep moving along here. Open up. Multi-scale linear transform. Okay. Now down here we have RGB components, we have luminance, and chromiance. We are going to work with the luminance channel. Some people use RGB. So open up the preview. That's a real-time preview. And as you can see, this preview is the same as the actual picture. So bring it back here. Okay, like this. And on level 1, hit noise reduction. And take the amount and bring it right down to about 30, 35. And you want 3 iterations. 1, 2, 3. That's down here, iterations. Okay, so at this point you can go before, after, and already I, not being YouTube video, can see a big difference. It's already softened up the image quite a bit. So level 2, wavelet 2, the second level of all those pixels. Again, noise reduction. This time bring this to 2.5 down to 30% or 30. Right? Yeah, about 30. And leave 1 iteration. Third level, noise reduction, down to 1.5, all the way down to 25. You can experiment with these, by the way. 1 iteration. Again, let's move this over a bit. Before, after, Before, after. Huge difference. Much, much smoother. And finally, at level 4, down to 1000, way down to about 25 again. If you go too far and you push it too hard, gotta wait a second, my computer's slow. Before, grainy, after, smooth. Grainy, smooth, grainy, smooth. And the stars are staying about the same size. I'm also looking at the galaxy here. Grainy, smooth. Perfect. So 3, 2.5, 1.51, 35, 30, 25, 25. Good enough. So let's close this because we're happy with that. And go back to the original image. Drag, drop. And just give it time. This may take a few seconds. Sometimes I have to pause the computer or pause the recording. Done. Okay, let's just zoom in a bit. What do we got? So the background is much, much smoother. And now back to our preview window. We're going to change a few things. We're going to reset the bottom here. Reset. Drop down the target to chromiance, which is the blotchy blue-red, and go 7 layers and open the preview. Give it a few seconds. This is also computer intensive. Again, layer 1, noise, everything at default. Level 2, noise reduction. Level 3, noise reduction. Level 4, noise reduction with about 80%. Level 3, 80%. Leave it there. Give it a second. Now look at here. There's before and after here also. Before. Give it a second here. Okay. Before. After. Sorry. That's before. You can see the greenish, purple, bluish blotchiness. And when you hit this, it's a nicer, softer gray. So basically it blended out as much of the chrominance as possible. So before, after, before, blotchy, not so blotchy. I'm happy. Galaxy also. Before, after, next. Close. Go back to your primary image and drag and drop. The multi-scale linear transformation denoising mechanism, if you wish. Later on, there's other denoising tools that we can apply if need be on this target. But this is A to Z, Pixinsight, get me to the end quick. I want to show my friends. All right. So everything up till now seemed to have worked pretty good. We can remove the little preview. Our galaxy looks nice. Our background's much smoother, not as blotchy as before. And now we're going to unstretch. Because now, if I go to my notepad, it's time to go linear. So, in other words, now it's time to really stretch the image for the first time. And if we had a thing here, it would be like 8B going linear. Yeah, that's learning how to spell. Going linear. No, let's save that. Bring it down. All right. So, a couple of ways to stretch. Normally and always, the screen transfer function does do a good job for doing that. Again, I think I closed the histogram transformation tool, so now I can't see it. And I think what I'm going to do is I'm going to bring in my icons because this is really wasting time. Histogram. Yeah, I'm going to have to bring those in. It was probably actually there, but I don't see it. So 3 ways to stretch this. Automatically, where you would just use the screen transfer function and hit the nuclear button. That should stretch it. Make sure you've selected your GPA. Drag this onto here. Reset the screen transfer function and drop off the triangle onto the image. And that'd be a full hard stretch. Which didn't work because I, being silly, forgot to take the mask off. How do we know? Because the tab is brown. So let's undo that. Guys, don't forget to remove your mask. There you go. Let's try again without the mask and see if we get in. There it is. All right. So I don't do it that way. Why? Because this is too harsh. This will take the pixels to the highest level, and even though it shows no clipping, it's not the way I would not want to do it. And I think you guys should also use whatever version you want. But I'm going to undo. That should bring it back to black. I'm going to reset this. I'm going to minimize my screen transfer function. And that was number 1. Automatically let Pixinsight do everything for you. Or open up your preview again, window, and you're going to stretch it to your liking. And here's how close the bar is stuck to the wall here. If I go here, I mean, we're jammed on the left hand side of the histogram, but that's going to change in a minute. So grab the midpoint, start pulling. Watch your galaxy here. So apply it with the square box once. Come back, hit the reset, pull it again. What I'm watching for is the histogram on the top. This guy, I'm trying to keep him a quarter of the way in and no further. So I'm going to bring him up a bit. Hit the square. Reset. Bring him up a bit more. Stop there. And now go to the black point, which is the hard left triangle on the bottom here. And I'll keep an eye on these shadows here. These guys. Don't want to clip this too much. So I'm going to bring it up. Darken, 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 darken. As soon as it hits 1, you're allowed up to 500, but let's say it hits 1. There it is. See the 1 down here? I'm trying to put my mouse on it, but I can't. 0%. So that's my dark. You could pull the light up a bit more. Always watching your galaxy, not the histogram. That's your guide. That's reality. So again, hit the square to apply because you really like this image. Once again, I'm going to undo. I'm going to put up. I'm almost there now. That's about as max as I want to go. A little bit more. A little bit more. Pull back on the dark. Now we'll start clipping a lot of pixels. Out of 18 million, I can afford to throw away a couple of hundred. Okay, so before, after, before, after. Basically, I've nicely darkened the background. The galaxy is really standing out. So this time now, I will actually close the preview, drag and drop right onto the image. That's it. Okay, track. Not going to close it because you know what happens if you close it. You lose it. Put it here. I'm going to put this up here. Again, file, save as. This one, because I've gone almost to the linear point, is now not A but B. So now I have 3 copies to be safe. Now, you know what? Right now at this point, if I wanted to, I could say, you know what? I'm happy. This is fantastic. I can put this on Flickr right now or Astrobin or send it to my aunt in Australia and say, look, auntie, look what I've done. And this is a beautiful picture. Like right now, as is, with 30 seconds. At ISO 3200, not recommended. I can explain that later why. There's a lot of data here, and the stars are really nice, and the color's nice. But let's continue. We're now non-linear. If I try to shrink that back to a black screen, let's try it. Nothing happens, and it won't. This is it. This is our image that we can work on from here. So let's do something. Let us bring back our luminance. Remember this guy? Mask. Now, it's already in memory, so you could go mask, select a mask. Well, which one? Well, the one down here, Loom. Okay, boom. Now it's on. How do we know? Control K, 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 K. That's your keyboard, by the way. Control K. This is a Windows, not Mac. So show, don't show, show, don't show. Let's make a preview window around the galaxy's core. And let's shrink that a little bit. There we go. And let's bring in HDR. The purpose for HDR, in normal photography, it does some crazy things. It's like it makes things surreal, like you're from another planet. But in astrophotography, this HDR multi-scale transform does a lot of nice things, like stops the core from burning out, and brings out the lanes. So let's go all default. Let's not touch anything, not even de-ringing. Let's just drag and drop. Here we go. Let's see what happens to the galaxy. Did you see that? You see this little blue arrow that goes back and forth, back and forth? Click on it. Before, after, before, after. Without changing anything. I love it. I'm just going to undo it. I'm going to do de-ringing to protect the start. One more time. I'm going to try it again. Before, after, before, after. We're going to keep that. Drag, drop. Now the lanes are going to pop out. Way more, way more. This will take a few seconds. 50%. This computer is HP Envy, 12 gig of RAM, quad core times 2, so 8 cores. It's okay. It does pretty good. And done. Well, let's have a look. Goes down, put this in max mode, move this over, go before, after. Before, burned out core, after. And the lanes are really snappy. Gotta love this. Alright, let's close HDR. What are we at here? We're already at, okay, probably close to 20 minutes of video. Okay, so after we've done some nice HDR on the galaxy itself, we're going to do a little bit of histogram, retouch the local histogram equalization. Again, you've already have a preview selector, so just open up the real-time preview and let's have a look at it. Now it's going to be really ugly, but we don't want the whole picture. We drop down menu, preview only. And take your slider and bring it right back down to like 200 even. Voila. So without touching anything, before, after, before, after. So on the after, the lanes, the dark lanes are really starting to come in. Keep in mind the ISO was high at ISO 3200, so it was extremely noisy. The chip must have been red hot. And, oh, I noticed my Galaxy's still not the way I want it. Those are supposed to be at the top. My bad. We can fix that in a minute. Or just leave it. So, by changing the contrast limit, and I'm going to exaggerate, watch the lanes here. I'm going to go to like a 5. Before, after, before, after. Those lanes down here just pop right in. Now there's the radius of the kernel of each pixel. In other words, smaller sections. I'll let go. Before, after, before, after. That brought in a lot of smaller detail down here. Or a large kernel radius of about 100 or over 100. Let's see what happens here. Before, after, before, after. Takes larger sections into consideration. That part, it's up to you to use your eyes. Do you want a larger section or a smaller section? And look at the difference. I'll go again, I'll exaggerate. There. Or there. And it really depends on what target you're looking at. If this was a Trifid, it would do something. If this was Orion Nebula, it would do something else. So before, after, before, after. Plus it brightened overall the whole target, which is very nice. Let me just do it one more time. I'm going to go down here. Yeah, that darkened it. So probably around 80 before, after. Okay, let's keep going. Remember, the image has quite a bit of noise because the camera was running really, really high ISO control. Making sure it's still the Galaxy that I'm selected. So drag and drop at amount 2. Now, if I increase the amount, do you want to see what it looks like when you increase the amount? Let's look at this again. Preview 1. Watch if I go to 500 or something. Look at the noise come right out. Before, after, before, after. When the data is really, really good, you can push that to the limit, but not so here. Go back to 180 or 200 because we don't want to make it too noisy, because if we do, we'll have to apply more noise reduction later, and that destroys the image. Drag and drop. Let's watch the image. M31. This also takes time. Oh, pretty good. Not bad at all. All right, close. I don't think I'm going to be revisiting this. If so, I'll have to open it up. All right. So what do we got? Here we have the Galaxy. Zoom in a bit. We have the lanes are really sticking out nice. We have some nice HA region here. It's nice. I honestly think I have this Galaxy upside down again. I'm going to remove the mask. And keep going. And at the end, at the very, very end, we can turn it right side up. I'm so accustomed to having those lanes here at the top and this section at the bottom, but that's okay. Let's keep going. We've accomplished our purpose. We've had so far. Let's review. What have we done? What have we got so far? We cropped it. We neutralized the background and we corrected all the nice star color, including the Galaxy's color. Then, before we stretched the noise, we denoised it. You never remove the noise. You actually, it's called noise reduction. So we reduce the noise to an acceptable level. First in luminance, which is RGB. Second in chromiance, which is the blotchiness. All of that can be done in Photoshop, by the way, for those who have the Photoshop tools like Annie's. and carbonis. Okay, so and then now we've done some HDR to lower the we don't want to blow out the core, so we fixed that a little bit. Then we brought out the lanes. So what's left? Well, we could do a little bit of star reduction, and it gets a little tough here. So for the star mask, I'm going to give you some basic, quick and dirty, I hope this works kind of thing, because this star mask can take over an hour. So we're going to go right up to about 4,000. And we're going to go 8 layers, and we're going to reduce that to 1 for the bigger stars, and the aggressiveness down to about 14, and just a little bit back on the truncate. You can just pause this later and copy these if you want. But let's see if we can create a small preview, and I literally mean small here, because I want to just see the stars, and drag the star mask and create it on a small section. If it works on a small section, it'll work on a large section. Most people do not even do that. If I still have the mask applied, I believe it's gone. Yeah. This is going to be a different mask. It'll be a star mask, not the target mask or a galaxy mask. And then we're going to bring the green down a bit. There's too much green in that galaxy, or the background. There's no green in space, so let's remove it. But let's just see. This takes a while also. Okay, so put this at its normal size. Put this at its normal size. Put them side by side. Do these stars. Cover these stars. Yes, and it's not perfect, but it's not that. And yes, my stars are a little square-ish. It may be the smoothness, but perhaps I should have stayed at 16, but it will still accomplish its purpose. So close the test part of it. We have to pause this, and of course go back full size, create a mask of the entire image, and I'll be right back. So the mask is made. We'll minimize that, and we'll resize this guy. Mr. Luminance, you're in the way. And we'll take our mask, same as before, drag and drop it on the primary image. Don't close it, minimize it, put it down. Again, click on the image, control. So all the stars are now not protected, and the background is. Right, because we want to do some star shrinking, if you want to reduce the size of the stars a little bit. So back to our preview, which we have a mask because we know, because it's a nice brown yellow and not just black or gray. Now, how do we reduce the stars? There's many ways. A simple way is, if I can find it now, look all over the place with this morphological transformation, and the other one, of course, is using deconvolution. But let's try this. So we have our nice little preview, and we have our stars, and because this is a Canon DSLR, we can try about 9 pixels and push a little round circle here to grab. It's all really test. Now there's two types of operators: erosion, shrink, or morphological. Let's first start the first simple. I said this before. Star masks can take a couple of hours to get it right, because each target's different on all the stars. Let's just drag and drop on this, and let's see if they shrink. Boy, they sure shrunk, didn't they? So before, after, before, after, before, after, before, after. Let's go back and let's just take the amount down to maybe 80%. So again, drag and drop, before, after, before, after. I really like that. Let's drag and see how far we can push those stars back, so that they don't become prominent, but the galaxy becomes prominent. Okay, so this effect here, it's okay, and the stars are definitely way in the background, but for some people, they don't like it. They say, where did the stars go? Well, they're all there, but they've lost that high intensity. So let's hit the undo morph, redo, undo, redo. So it depends, like, what do you like? To me, I kind of liked all those stars being there, but at least I showed you how to lower the intensity of the stars in a nebula or a big star field. Or we could go back to our preview again, before, after, before, after, before, and go way down to 50%, and maybe lower the element down, if you want to 7 from 9. But let's leave it on 9. Drag and drop. Before, after, before, after. Isn't that better? Isn't that much more subtle? Drag and drop. They'll still drop by half. I want them to drop by half. I don't want them to disappear. Okay, that's nice. I've seen some pictures where the stars are almost all gone, but they're still all there. They're just not overwhelming. And we're just going to, no, actually we're going to leave the mask for a second, because now we're going to close morphological transformation. And I'm just going to quickly go to, I'm going to do a, I can check, but I thought I had curve. Yeah, it's right here. I'm going to take the curves, again, real-time preview of this box, which is all it is. It's just a real-time preview. Whatever you do will be affected immediately, because you want to see it. And I'm going to go over to saturation and look at the stars. I'm going to over-exaggerate. Here, there, the stars are bright yellow and blue and all kinds of other colors. So it'd be like before, after, before, after. Now some people say, I really like my stars to be colorful and I want them to stand out. So I'm going to just drag this and make the stars really blue and really yellow, whether yellow or blue. And there it is, without touching the galaxy as much as possible, because the galaxy is actually completely covered, protected in the mask. Only the stars are affected. So let's bring this back. Let's go back to RGB, back to preview, and if you find your stars too bright in the saturation, you can bring back some life to them. Let me just go back to this again. I'm going to reset that. Oh, don't forget to reset, because if you don't, it doubles and quadruples, and first you know, you've applied the saturation 100 times. So back to RGB, which is black. Darken the stars. Brighten my stars. Even though they were still colored, I can still bring some life back to them. Just let's go before and after. Before, after, before, after. So not too saturated, and we're just going to bring them back to life a little bit, and there it is. Reset. If you if you hit the check mark, you actually see the histogram of the entire stars, because they're masked. And isn't there a lot of green? There's a lot of green. All right, so let's close. No, don't close it, because you'll lose it. Let's go here. The mask, remove mask, and let's bring in this green machine. You guys are probably looking at it right now, saying SCNR. So here I'm looking under A, and the whole time it's C. So color to remove, green cast, amount 100%. You see that? I just wasted 45 seconds. Drag, drop, and let's see if most of that green is gone in the very, very back of the background. If we go before, there's a lot of green patch. It's a lot of green patchiness here. You can barely see it, but I found that when I did it at 100%, it was just too much, and my galaxy changed color. I didn't like it, actually. So you can mask the galaxy and just do the background, which I may end up having to do anyways. But if I do that, I found that my galaxy turns purple. So okay, I'm going to undo it. Yeah, just leave it the way it was. All right. Okay, so we're almost finished in terms of what we, the steps that we can take. Remember, again, this is ISO 3200. So the image is buried in the noise, and there was no way to really clean it up properly. The better the data, the more you can push Pixinsight, and Pixinsight does have a way to get down to the bottom of things real fast. And I don't think you have to provide as clean as data as possible. So we can talk about that on another video. So what do we do now? Well, at this point, again, these are steps. It wasn't about the image per se. It was how do I get from A to Z, and we're at like W. All that's left is X, Y, Z. So right now, because everything looks very nice and the galaxy's nice, it's standing out quite a bit. We can improve the contrast again by using curves to a degree. So if we open curves and open the full image and pick a spot right down there, see how it shows up right about here, and then pick a spot in the galaxy, how that's way up there. Okay, so basically what you could do is brighten the galaxy up and then just darken the lanes a bit, the background. I would surmise that if you're going to do it this way, there's before and after, a mask would be very important to keep the background put and only deal with the center of the galaxy. And because we're going to go in that direction anyways, I'm just going to reset this back to square one, and I'll show you how to use the range selection. Open up range selection, it's in the menu. Do a preview of the entire galaxy. It should be pitch white. Okay. Lower the limit until you only have the galaxy coming into the center. A bit more. smooth out the mask so it's really, really, really smooth, because you don't want an abrupt end between the whiteness and the dark. Again, you can back up a bit and bring some more in. Okay, close the preview, create the mask. Then we're going to drop it on the galaxy and how well it did. Okay, so this mask is fairly gray here on the outer edge. If you want to, you can reopen your, let me see, I guarantee you I closed curves, didn't I? Didn't I close curves? Don't I learn my lesson? I never, always do things backwards. Curve selection. Yeah, you can tell I'm on some pretty heavy medication for my sickness. So let's open that up and let's darken the background of that mask. Yeah, I mean, we don't want to darken the galaxy, but we don't want the background to show through. Hit the square and that mask should be darkened. And there it is. It's much darker. Bring here. What do we do with masks? We drag them onto the tab. We minimize them. We put them off to the side. And then we Control K the keyboard to say, oh, it's just the galaxy sticking out. Right. That's all we want. Good. Of course, we're going to want a preview of the core of all that. We're going to look at that preview, zoom out. And it was about maybe a little bit of contrast in curves. Remember always to reset and to check mark so you can see the histogram, and of course preview of the preview. This is a real preview. And here you can, like I said, darken the galaxy a bit if you want, or you can brighten the darker areas or really make it dark. Don't exaggerate too much like I'm doing, but I'm showing you that you can do it. So before, oh, hold on, computer always freezes. Preview 1, before, after, before, after. Be careful you don't take out too much of the galaxy. If I do this too much, I'm bringing in more noise. And what have I just done to my core? I burned it out. So this is before I touched it. This is after. But yeah, so this is kind of, we're like adding a bit of contrast. I'm just going to do it on the preview. Down. Before, after, before, after. Maybe I did too much, and maybe the galaxy will be darkened a bit too much. Let's have a look. Drag and drop. Yeah, so, you know, basically I've taken all the gusto out of the outer edge. So don't do that. Hey, I'm sure you know what not to do. There you go. On the other hand, there's this, where you can really bring in the galaxy a lot if you wanted to. And that probably is much better. Let's do that instead. Always concentrating on keeping the overall image the way it should be. So the galaxy's a lot brighter, but you know what happens when you do that? You know? Make sure you always reset. I'm losing my contrast again. There, much better. You know you can reiterate this 10 times, eh? There's always back, 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 and then there's add, and remove. Like you can make changes that much better. See how this column back down again? I'm very happy with that. And finally, we still have a mask. We still have a grid. We also have, let's bring back our preview for the last time. Down a bit. And now we're going to do what everybody's favorite part is, reset. And now the galaxy is, for all intents and purposes, could be, the color should be brought into this because it is just a bit white. So the danger here is putting too much color into Andromeda. I've seen it bright neon blue. I've seen it dark gold. And I'm just going to go before, after, before, after. Put as much color as you want. Let me go see if I can have a look at the preview. Before the color, after, before, after. Yeah, that's the danger in overcoloring things. Is the saturation starts to take over, and it's not. It also accentuates the noise, which was the blotchiness, which we took out as we took a lot out of it, but there's still some. Gonna drag this on there. Gonna make the galaxy a little bit a nice lighter bluer color. It also brought out some of those hydrogen alpha areas, which is blue and red, as you can see here. And yes, the stars are a little bit too saturated. Again, as you wish it, not I, because I don't know what you guys' particular tastes are, but you can go from the very beginning to the very end using the steps that I just followed through in the last, must have been an hour now. And you end up with a final image at this point here. If you want, if you feel the need to do a bit of denoising at the very end, you can, and you can use ACDNR. Remove the mask though, because it's capable of making its own mask. So we're going to remove the mask. See, there's too much color and the noise is too prominent. But these are 60-second subs at ISO 3200. Let's open up the lightness mask preview and open up the thing. Let's click on preview. That should go white or dark. And everything in black will be protected. Everything in white will be attacked. So in this case, if we were trying to denoise or do some noise reduction on the background, because right now I'm masking the entire galaxy and the background, this would work great. But I'm also saying to don't touch the galaxy. But in reality, I do want to touch the galaxy because the galaxy has been quite is quite a bit of noise in the center. So make sure you lighten things up quite a bit, except for the very, very core. Okay, so just adjust these three so that everything white is susceptible to being noise reducted. That's not even a word. Okay, uncheck preview, check lightness mask, and because you're already set at 90 and 1.5, you can now go before. Here goes my computer again, doing this little game. Before, after. Let me just hit reset here again. Yeah, it's something wrong with my computer. Okay, so again, a little willy turn. Okay, so before, after. Yes, oh, there's a huge difference. It really softened down the image. Let's bring it up. There's also TGV denoise, which works even better. We could have done that at the very beginning, but the data was at ISO 3200. So this video is not about noise reduction. It's about how can I take all my subs, throw them in at the end of this video, do those 10 or 12 steps. Thank you, and remove. And this is, for all intents and purposes, the entire Andromeda's there. The galaxies are nice. The stars have been dimmed down. The color's nice. And of course, the lanes are sticking out for 30 seconds. I would have gone with a lot more, maybe 60 seconds, and I would have done it for 6 or 8 hours instead of just an hour and a half. Or, for example, this is 5 minutes. This total integration here is 5 minutes. So it is what it is, right? All right. So file, save as. We're going to change that to a fits, and then just say yes. And of course, I'm going to get 16-bit fit. And I'm going to go again. I'm going to go save it, and this time I'm going to change it to a TIFF. And that's going to be a 16-bit TIFF if you want to go into Photoshop and do some more, whatever you want to do. And then finally a third or fourth time, and this time it's going to be a JPEG, something I could just throw on Flickr, on Facebook, on Instagram, or whatever. 80%, no profile, okay, and now I have them all there. All right, so Guillaume said, well, he sent me the one that he did from Deep Sky Stacker. Let's have a look. So this is going to be a comparison, not really, but kind of this to that. Let's look at that. Let's see what he did. So his is called What I Get from Deep Sky Stacker, 95 meg. And mine's 120 meg. Okay, so let's just get rid of all these things here. Okay, so again, I'm going to try to turn the galaxy around. That geometry be 180 maybe. Yeah, and I'm going to flip it the other way again. This time I'm going to do like a good old horizontal flip. Yeah, so now they're identical. So, and I'm just going to quickly do a kind of a crop thingy so that they kind of they both look alike. I believe it starts about here. It's going to start about here. Just have a quick look down here. That's a lot closer. Yeah, okay, so here. Okay, so it's going to be tough. Minimize or make it smaller. Put this over here. Put his here, take mine, make it a bit smaller. I'm going to try to fit them in both beside each other as much as I can. It doesn't matter. Up, up. Yeah, that's about right in terms of image scale. So, yeah, the stars are all in the same position, basically. So this is Deep Sky Stacker. He says, Mitch, this is what I get using Deep Sky Stacker Preview 1. And with Pixinsight, basically that's what I brought out in the absolute simplest, do it in an hour and 15 minutes video, because I had to rush through it and I didn't have enough data. And thank you, Guillaume. Forgot your last name.